All right, so when factoring this one, first of all, the thing that should jump out at the start here is that it's an 8 and a 4 for our exponents. That tells us that since the first exponent is double the other, that it's going to behave like a quadratic. And when it behaves like a quadratic, that's going to give me x to the fourth and x to the fourth in both parentheses. And just like with the quadratic, I'm going to add to the middle number and multiply to the last number. So in this case, to add to negative 17 and multiply to 16, it's a negative 1 and a negative 16. Now the tricky bit with this one is that both of those parentheses can actually factor further. If it was an x squared minus 1, we could factor it further. Well, x to the fourth also can factor further. In fact, both of those are going to break up into parentheses that look like those. All right, so now that we've broken the fourths up into squareds, we now need to look at each of those parentheses and see if they can break down any further. And as it turns out at this point, some of them can and some of them can't. X squared minus 1. That one can actually simplify further. X squared plus 1. That one cannot. So I'm going to be able to factor down x squared minus 1 and the x squared minus 4 further. When I do that, each of those is going to become their own parentheses. But the x squared plus 1 and the x squared plus 4, those will not break down further. Now I want to remind you why they do not factor when they're a plus. The only way that I can end up with two terms, x squared and a number, the only way that I can actually factor that is if it's a minus, because there's no x term in the middle here. That means it's a 0x. That means we're adding to 0. But the only way to add to 0 is a positive and a negative of the same number. But a positive times a negative will always give us a negative, so it's impossible if it's a plus. All right, so we do have some minuses, so we can factor those. So we go ahead and factor those out, and this then is our final answer. You'll notice that in this final answer, the x squared plus 1, since it didn't factor any further, it just stays x squared plus 1. Same thing with the x squared plus 4. And then every now and then somebody says, yeah, but what about this? Because that's also a minus 1. Can that factor further? No, because it's not x squared. That's just an x minus 1, not x squared. So it's got to stop there. All right, so today we're going to be actually getting into problems like these where we find the solutions, or as they're also called, the zeros. So you've actually seen problems like this before, just it was when we were doing our quadratics. So for instance, remember when we were doing it before, you might have had a quadratic that looked like that. And we would do the x plus 1 and the x minus 5. And in order to solve that, we'd say, well, what plus 1 is 0? And what minus 5 is 0. This is actually going to be the same idea, just there's 3 parentheses instead of 2 for that first one. So if I'm going to solve number 1 to find the zeros, it's what makes each parenthesis equal 0. So what plus 1 equals 0? Negative 1. And what minus 5 equals 0? 5. And what plus 6 equals 0? Negative 6. So those are our 3 solutions for that. Now with that in mind, go ahead and write down and work out the other problems. And as always, make sure you're writing the problem and the answers, because that way if you're looking back at it later, it's useful. Because one without the other isn't at all useful as a reference. For the second one, a lot of it's fairly straightforward, but the one part that sometimes will get people a little bit hung up is the x that's sitting out front. What can I plug in for x there that will make that part of the equation equal 0? Well, 0. Oftentimes, we try to make it more complicated. We try to think, okay, well, what can I do to x to make it 0? But you're not doing something to x, you're replacing x with something to make it be 0. And so that one just ends up being 0 there. And then, of course, from the other ones, we're just flipping the signs because we're saying what makes that one equal 0. So our solutions for that second problem are x equals 0, 2, 4, -8, and -3. All right, for the third one, we now have x minus 8 squared. And the question is, what does the squared do to it? Because without the squared, we just look at it and say, well, what minus 8 is 0? So we'd say, oh, well, this part here would give us 8 as a solution. Well, let's see if that would still be a solution with the squared. So if I plug 8 in, 8 minus 8 is 0. What's 0 squared? 0 still. Okay, so the squared didn't change anything. So it's still going to be an 8 for that. And with the other one, it's still going to just be -7. Because negative plus 7 is 0. And 0 cubed is also 0. So the exponent doesn't change that part. It doesn't change what makes that equal 0. And then for the last one, we start with 3x squared here. What can I plug in for x that makes that equal 0? 0. Yep. Anytime there's nothing added or subtracted, it's 0. And the reason is because 0 squared is 0, and 3 times 0 is still 0. And then, of course, so that gives us 0, then x plus 4, so that's got to give us a -4. But what about the 2x minus 5? What can I plug in there? It's not 5, because 2 times 5 is 10, 10 minus 5 is 5, not 0. Now, many of you got the pattern down. You can look at it and you can know. If not, that's okay. You can always solve it by setting it equal to 0, because if you solve that, it'll tell you what can you plug in for x that makes it equal 0. So I add 5 to both sides, and then I divide by 2. X equals 5/2, 2.5, or 2.5, depending on your preference about how you write it. They're all equivalent, and so they're all right. So if you can do those, you can do these. Because in each of these problems, you're given the zeros, and you're asked to write the equation that would give those zeros. So it's basically the same thing we just did, except backwards. So again, when you do this on your paper, make sure you're writing out both the original problem and your answer, so it's useful when you look back at it later. So for that first one, we're going to write an equation. We're saying, well, what can I plug in -3 into so that it would be 0? Well, it'd have to be x plus 3. And then the -2 means we had an x plus 2, and the 1 means we had an x minus 1. So there is your polynomial that gives us those zeros. Now, one little aside here. Sometimes somebody ends up asking me, do I have to multiply that all out, or can I leave it in that form? You notice the original question here just said write a polynomial function with the given zeros. It didn't specify a form, and so since it didn't specify a form, you can give it in whatever form you want to. And since you'd always start with this, just leave it there. You don't have to put it out in a standard form. Now, if it's specified in standard form, that'd be another story, but thankfully it doesn't. All right, now for the second one, most of those are fairly straightforward. Now, we do need a reminder, though, in order to get 0 as one of our zeros, in the equation, that means there's going to be an x. Just an x. And so if I wrote it out in the same order as what the zeros were given to me, I'd end up giving an equation that looks like that. But, you know, it looks awkward to me. I don't really like the x sitting by itself in the middle of the equation. If for no other reason, it could end up looking like a multiplication symbol if we weren't really careful. And plus, it just doesn't follow convention. Convention is that normally, if we have an x by itself, we put it first. So that's what I would suggest that you do. Whenever there's something that's a 0, put that part first when you write the equation out. All right, now for the third one, notice the -4 comes up 3 times. Now, of course, the -4 means that we're going to have an x plus 4 in our equation. But since it comes up 3 times, and because I don't really want to have to write x plus 4, x plus 4, x plus 4, go ahead and just write it as x plus 4 cubed. And then the x minus 3, x minus 5 to take care of the 3 and the 5 that were also there. All right, and finally there for that last one, notice the 0 appears twice, so that means we got to have an x squared. And the 1 appears twice, so that means we have to have an x minus 1 that's cubed. And of course the x minus 8 comes from the 8. Now, one little side note here. This would give us those zeros, but so would it if I had like a number in front of the x squared. And oftentimes somebody ends up saying, well, which is it? Because really there's an infinite number of different variations where we put a number in front of here. And by the way, it would only work if it was a number that we multiplied onto it like that. But this is sufficient without that number there. While the other still technically does give us an equation with those zeros, why make it more complicated than you need to? So yes, it does work, but go with the simplest version if you're trying to decide. It just makes your life a little easier, and it's a simpler way to look at the problem. All right, now the last one we're going to be taking a look at solving is this problem. Now hopefully this problem looks a little familiar to you. This is the same problem that we factored at the start of class today. The x to the 8th minus 17 x to the 4th plus 16. The difference is, though, this time we've written it as 0 equals, and we're being told this time that we're going to solve it. So we've been solving a number of polynomial expressions, but they all were factored. So how do you do it if it's not factored? You factor it. So step one when solving a polynomial is to factor it. Now, thankfully, because of the work we did earlier, we already know the factored form of this. We know what it ends up looking like. So this is our factored form. Now, I didn't show all the work again because we already had done all the work at the start of class. All right, now from this point, we can now solve it. When it says solve, we're trying to figure out what x equals. It's going to make it equal 0 because it's equal to 0 over here. And from that factored form, we treat it just like we did with the other one. So most of it's fairly straightforward. So like what minus 1 is going to equal 0? It's got to be a 1. Okay, then what plus 1 equals 0? Well, that's got to be a negative 1. But what happens with this one, the x squared plus 1? What makes that equal 0? Well, there's a couple hints that tell us. One, remember that one could not be factored. That's one hint. The other hint is coming from just, well, what if we try to brute force it and actually do the solving to see what makes it equal 0? If we went through this work, we'd end up with x equaling the positive or negative root negative 1. Or, remember what root negative 1 equals? I. So, x would equal an imaginary number here. This problem did not say anything about imaginary numbers. It did not say give real and imaginary solutions. It just said solve. Unless it specifies to include imaginary solutions, just give the real solutions. So, because that was not factorable, because it gave us an imaginary number, we will get no solutions coming from that particular set of parentheses. So I will skip that in finding the solutions and then go on to the x minus 2 next. And so we end up with actually only 4 solutions for this problem, even though there were 6 parentheses. The ones where it was just x plus or minus a number, we could solve those. The x squared plus 1 and x squared plus 4, couldn't get any real solutions out of those, so they just are skipped over basically.